Welcome to your Algebra 2 Capstone Lesson 3 on factoring. All right, this is review of all kinds of factoring that we've talked about, so it will probably go pretty quickly. Remember, factoring undoes multiplying. Always look for a greatest common factor, GCF, first. So for our first example, we're going to factor out the GCF. We've got 7x plus 28, so we can factor out a 7. And we will have 7 times x plus 4. We know that we factored correctly because if we were to distribute this 7 back across the binomial, we would end up back at 7x plus 28. 32m plus 24. Let's see, 8 factors out of both 32 and 24, and so the factored form is 8 times 4m plus 3. 8a minus 9. Well, 8 and 9 are relatively prime, so this whole little binomial is prime. There's nothing we can factor out. All right, part D we're going to leave for you to try on your own, so go ahead and pause the video and knock out that problem, and then join me on the next example. We're going to continue to factor out greatest common factors. We've got 100 times m to the 5th minus 50m to the 4th plus 25m cubed. So let's look at the coefficients. We can factor 25 out of each of those, and then for the powers of m, you just go with the smallest power. M cubed is the smallest power, so we're going to factor out 25m cubed, so that's going to leave us with 4m squared minus 50 divided by 25 is 2. M to the 4th power, we factored out 3, so we're going to have m to the 1st, or just m, and then plus 1. Okay, for part B, we've got 5x to the 4th y cubed plus 15x to the 5th y to the 6th minus 20x to the 4th y to the 6th. So let's see, we're going to factor a 5 out for the coefficients. And let's see, x to the 4th, because that's the smallest power of x, and y cubed. So we'll have 5x to the 4th y cubed times 1 plus 3xy cubed minus 4y cubed. All right, now this next problem is to kind of help us lead into factoring by grouping, but it's also an awesome way to save yourself some trouble if you're trying to add. If I have x plus 2 times x minus 4, and then plus x plus 2 times x minus 6, at first I might think, okay, I've got to FOIL these two and FOIL these two, and then add together. But look what we can do. We have x minus 4, x plus 2's, and we have x minus 6, x plus 2's. Because the x plus 2's match, the other factors in those terms tell us how many of them that we have. So we can bring these out, factor out the x plus 2, okay? In just a second, I reordered it just to kind of help you think of, okay, this is telling me how many x plus 2's I have. This is telling me how many x minus 6's I have. We can factor out the x plus 2's and in brackets do x minus 4 plus x minus 6 because that's how many x plus 2's I have. So in brackets, I'm going to do x minus 4 plus x, because I have a plus right here, that's where that plus comes from, x minus 6, and then here's the x plus 2 factored out. Well, x minus 4 plus x minus 6 is going to give me 2x minus 10 times x plus 2, and now I can just FOIL once. And so I'm going to get 2x squared plus 4x minus 10x minus 20, combine like terms, and I get 2x squared minus 6x minus 20. Let's do one more like this. I've got y minus 1 times y plus 3 minus y minus 1 times y plus 3. So my common factor is y minus 1. So I have y plus 3 y minus 1's, and I'm subtracting from that y plus 4 y minus 1's. Okay, again, I'm going to put the common factor at the end and the other factors at the beginning. And so I'm going to scoop those up together in a pair of brackets and have y plus 3 minus y plus 4 times y minus 1. Now I have to be a little more careful this time because I do have a minus there, so I'm going to go ahead and show the distributing the minus across that second set of parentheses. So I'm going to have y plus 3 minus y minus 4 times y minus 1. And so let's see, y minus y cancels, y minus y is 0, and 3 minus 4 is negative 1, and so we have negative 1 times y minus 1. We're not going to have to FOIL at all. We're just going to distribute the negative 1. So we have negative y plus 1. All right, we've got k squared times a plus 5b minus m squared times a plus 5b. So I have k squared of these a plus 5b guys, and I'm subtracting from that m squared of these a plus 5b guys. So I'm going to bring the k squared minus m squared out front in parentheses, and then I've got a plus 5b, and then I'm going to FOIL. So let's see, I'm going to have a k squared plus 5bk squared minus am squared minus 5bm squared. And there's no like terms, so we're done. All right, we're going to factor negative 6r squared plus 5r in two ways, just to show you what effect this does. This one we're going to use a negative GCF. So let's see, I'm going to factor out negative and then r, because they both have r's in them. So I'd have negative r, negative 6r squared divided by negative r is 6r. 5r divided by negative r is negative 5. And so this is the factorization if I factor out the negative. On the next one, we're not going to factor out the negative. And so we're just going to bring out the r, so I'll have negative 6r plus 5. So my signs change inside the parentheses depending on whether I factor out the r or the negative r. And that's going to be important when we do our factoring by grouping. We typically do this when there's 4 terms. Whatever is in the parentheses after factoring the GCF in the first 2 terms must be in the parentheses after factoring the GCF in the second 2 terms. If somehow we've messed it up by just a sign, that means we need to go back and look and see if we need to factor out a positive or a negative. All right, so I've got 6p minus 6q plus rp minus rq. Well, let's try, sometimes you have to reorder, but let's try grouping the first 2 together and the second 2 together. Okay, so I kind of color-coded it there. So for our first 2, you're looking to go, what do they have in common? Well, they have common factors of 6. For my second 2, what do they have in common? They have common factors of r. So I'm going to factor a 6 out of my first pair. So I'm going to have 6 times p minus q plus r times p minus q. The p minus q's match, so this is a good grouping. So just like I did before, I'm going to think of this, okay, I've got 6 p minus q's, and I'm adding to that r of the same kind of thing, p minus q's. So I'm going to have 6 plus r times p minus q. And that's it. That's my factored form of my original polynomial. All right, on this one I've got xy minus 2y minus 4x plus 8. Okay, I'm going to group the first 2 together, the second 2 together. The first 2 have y in common, so I have y times x minus 2. And I'm going to go ahead, because this is a minus, I'm going to factor out a negative 4. And so negative 4x divided by negative 4 is x. 8 divided by negative 4 is negative 2. And that works out because, look, we have the same value inside our parentheses. We have y, x minus 2, and then we're going to take away 4x minus 2's. So we're going to have y minus 4 times x minus 2. And we're done. All right, I'm going to let you do part C on your own. So go ahead and pause the video, stop, and do that one, and then come back and join me. All right, well, I mentioned this earlier. Sometimes you need to rearrange the terms before factoring. So I want to see a problem like that and work through it together so you can see what happens and how you handle it. Okay, so I've got 10x squared y squared minus 18 plus 15y squared minus 12x squared. So I think, okay, I'm going to just, so far, working with the first 2 as a group and the second 2 as a group has worked, so let's just try that. So I'm going to have 10x squared y squared minus 18 plus 15y squared minus 12x squared. Out of my green pair, my first 2, I can factor out a 2. So I have 2 times 5x squared y squared minus 9. And then out of my second pair, I can factor out a 3. So maybe that'll work, but I have 5y squared minus 4x squared. So that's not going to work. So I look at this and I go, okay, well, part of the problem was that I have x squared and y squared in here. I don't have x squared y. Why don't I try moving this y squared term here, and let's move the minus 18 just to the very end. In fact, let's just move the minus 18 to the end and shift everything else over. All right, so that's what I did. I'm going to shift everything over. So instead of leaving it like this, I'm going to move the minus 18 over here, color-coded it, where I've got the 10x squared y squared plus 15y squared minus 12x squared minus 18. That way, along with a 5, I can also factor out a y squared out of these two, and maybe that'll work. So let's look. I did 5y squared, so that left me with 2x squared plus 3 minus, remember we're going to factor out the minus, and let's see, these have 6 in common. So negative 12x squared divided by negative 6 is 2x squared. Negative 18 divided by negative 6 is 3. So I've got 5y squared times 2x squared plus 3 minus 6 times 2x squared plus 3. So I start off with 5y squared of these guys minus 6 of these guys. So I've got a total of 5y squared minus 6, 2x squared plus 3. And that's it. We are done. All right, there are special multiplying patterns that you have seen before that you need to know. You need to know the difference of two squares. You need to know the perfect square trinomial for both x plus y squared and x minus y squared. We've talked about them as multiplying patterns. You need to know them to be able to factor also. You also need to know sum and difference of two cubes. Okay, we've worked with these before, so I'm not going to spend a lot of time going over them. Please remember to look for our greatest common factor first. All right, we're going to factor each polynomial. I have p squared minus 100. 100 is a perfect square, so we do have a difference of two squares, and it factors to be p plus 10 times p minus 10. 2x squared minus 18, we do need to factor out a greatest common factor of 2 first, and then we have x squared minus 9. 9's a perfect square, so we can keep going, and we'll have 2 times x plus 3 times x minus 3. Part C, I'm going to leave as a problem to try on your own, so go ahead and pause the video and do that. All right, on this one, we've got m plus 3 squared minus 49z squared. Well, m plus 3 is squared, so we can just treat that as our first term that's squared. And let's say 49z squared, we can think of 7z quantity squared. So this is a difference of two squares. So we're going to have m plus 3 plus 7z times m plus 3 minus 7z. And we're done. All right, we've got y to the 4th minus 16. Y to the 4th can be written as y squared squared. Minus 16 is 4 squared. So we have y squared plus 4 times y squared minus 4. But look, 4 is a perfect square also, so we can keep factoring the second factor that we have, but not the first one, because it's a sum of two squares and that can't be factored. But difference of two squares, we can keep going. So the final factorization is y squared plus 4 times y plus 2 times y minus 2. Okay, for example 8, let's see, we've got 49z squared minus 14z plus 1. Let's see. It's not going to be a difference of two squares because we've got 3 terms. This is 7z squared. 1 is 1 squared. So this should be a perfect square trinomial. Let's just double check. Let's make sure that the first term is squared, and then we've got minus 2 times 7z times 1. We really could show the times 1 there. Plus 1 squared, this works. It's going to be 7z minus 1 quantity squared. All right, let's look. This one's a little more complicated because we've got 3a squared, which is 9, which is showing that 9a squared is a perfect square right there. And then let's see, the middle, the 48ab, let's come back to that. Let's write 64b squared as just one base squared. So we have 8 times b squared, so that works. So if this is a perfect square trinomial, the middle is going to be double the first times the last. So the first base times the last base. So let's see, 2 times 3a times 8b. Let's see, 2 times 3 is 6, times 8 is 48, and then a times b. This works. So this is going to be 3a plus 8b quantity squared. All right, on the next one, we've got x squared minus 2x plus 1 minus y squared. So you may think, okay, I'm going to do factoring by grouping, but I'd do an x there, and I'd have x minus 2. If I tried doing this, what would I do? A difference of 2 squared. I mean, that's not going to work doing 2 and 2. But look at this. This is a perfect square trinomial. We have x squared minus 2 times x, and there's an understood times 1 there, plus 1 squared. Let's group these 3 together. Okay, let's do these 3 and this 1. Because this is x minus 1 squared, y squared is a perfect square. So we can factor that out as the first base, so x minus 1 plus the second base plus y times the first base, x minus 1 minus the second base, so minus y. All right, 8y cubed plus 125. Looks like it could be a perfect, the sum of 2 cubes, and it is, because 8y cubed can be written as 2y quantity cubed plus 5 cubed, and so that would factor to be 2y plus 5 times 2y squared minus 2y times 5 plus 5 squared. And cleaning that up, we get 2y plus 5 times 4y squared minus 10y plus 25. And remember, this trinomial is always going to be prime. If we had double the middle, it would be a perfect square trinomial. But we didn't double the middle, so it's prime. I'm going to let part B be a problem to try on your own, so go ahead and do that. Pause the video, and then come back and join me for part C. We've got 2x cubed plus 2,000. There's a common factor of 2, so we have 2 times x cubed plus 1,000. 1,000 is 10 cubed, so we can factor that. And it's going to be 2 times x plus 10. Oops, there's a little typo there. Gonna fix it. Fix it in the next one too. All right. Back to our program. It is 2 times x plus 10 times x squared minus 10x. Remember, this is always the opposite sign of whatever is in the binomial. The binomial matches the original. And then we always end with something positive, so plus 100. And so it equals 2 times x plus 10 times x squared minus 10x plus 100. All right, we've got a minus 4 cubed plus b cubed. A lot like those difference of 2 cubes where we have a binomial. The difference of 2 squares that we saw where we had a binomial that was squared, you just treat your first base the same. It's just a minus 4. So I'm going to have a minus 4 plus b times a minus 4 opposite sign minus the product of the 2 bases, so a minus 4 times b plus b squared. So let's see. I have a minus 4 plus b. We didn't do anything there. Here we've got, we're going to have a perfect square trinomial. So a squared minus double the middle, so minus 8a, square the last, plus 16. And then let's see, negative a times b is going to give us negative ab, negative 4, so positive 4 times b gives us plus 4b, and then plus b squared. We don't have any like terms, so we're done. All right, we're going to now do general trinomials, and right now let's just talk about kind of the baby AC method. We're going to find all integers whose product is c and whose sum is b when we're talking about ax squared plus bx plus c. If c is greater than 0, then the signs inside the parentheses are the same and they take the same sign as b. And if it's less than 0, the signs inside the parentheses are different and the integer with the bigger magnitude takes the sign of b. Okay, so x squared plus 9x plus 20, you put your x's in your parentheses and then you think of numbers that multiply to 20 and add to 9, so 4 and 5. Since this is plus, they're both going to be plus. A squared minus 7a plus 10. Okay, numbers that multiply to be 10 and add to be negative 7 would be negative 5 and negative 2. So a minus 2 times a minus 5. Now we've got y squared plus 5y minus 6. So we want numbers that multiply to be negative 6 and add to be positive 5. So positive 6, negative 1. I'm going to let the next one be a problem to try on your own, so go ahead and pause the video and come back to this. This should be really familiar with you. All right, let's look at this next one. We've got 3a cubed plus 12a squared minus 15a. We're going to pull out greatest common factor first, so let's see, it's going to be 3a, and then we have a squared plus 4a minus 5, which will factor to be a plus 5 times a minus 1. So all in all, we've got 3a times a plus 5 times a minus 1. All right, now remember the AC method to factor out ax squared plus bx plus c when a is anything other than 1. You're going to identify a, b, and c, You're going to find AC, paying attention to a positive or negative product, and find integers that multiply to be AC and add to be B. And we're going to break up the BX term, and then we'll use factoring by grouping. All right, so I've got 3x squared plus 5x plus 2. So A is 3, B is 5, C is 2. So AC is 6. So we start going through the factor pairs for AC, starting with 1, 6. 1 plus 6 does not equal 5, so we cross that out, move on, and use 2, 3. 2 plus 3 does equal 5, so we can rewrite 5x as 2x plus 3x, and that's our next step. And then we do factoring by grouping, where we take the terms 2 at a time. And so let's see, out of the 3x squared plus 2x, I can factor out an x. Out of the 3x plus 2, all I can factor out is a 1. That's fine. So I'm going to have x plus 1 times 3x plus 2. That's my answer. All right, 6k squared minus 19k plus 10. A is 6, B is negative 19, C is 10, so AC is 60. So let's start going through our factor pairs. 1 and 60 is 61. 2 and 30 is 32. 3 and 20 is 23. 4 and 15, thank goodness, is 19. Since we want negative 19, we're going to do negative 4k minus 15k. And so all we've done is replace negative 19k with minus 4k minus 15k. And now we're going to do factoring by grouping, taking 2 at a time. And so we can do 2k out of the first 2. And that's going to give me 2k times 3k minus 2. We can do negative 5 out of the second 2, and that's going to give me minus 5 times 3k minus 2. So we have 2k minus 5, 3k minus 2. And that's it. It's factored. All right, I'm going to leave part C for a problem to try on your own, so go ahead and pause the video and do that one. Okay, welcome back. Let's do part D. So let's see, A is 6, B is 13, C is negative 5, AC is negative 30. So let's look at pairs that multiply to be negative 30. So negative 1, 30. Negative 1 plus 30 is 29. That doesn't work. Negative 2, 15. That does work, because negative 2 plus 15 is equal to 13. Now, if I'd had minus 13 here, what I would have done in this case is then just switch the signs. Because if I had minus 13 here, I would need positive 2, negative 15. But it's nice. It is plus 13, so I'm going to just replace plus 13r with minus 2r plus 15r. Let's see. I'm going to pair these two together. I'm going to be able to factor out 2r, and that's going to leave me with 3r minus 1. Out of my second pair, I'm going to be able to factor out a 5. So I'm going to have 5 times 3r minus 1. So I have 2r plus 5 times 3r minus 1. And that is my factored form. Part E, I've got 6m squared plus 7mn minus 5n squared. It might throw you off because we've got 2 variables involved. As far as figuring out how to break this 7mn down into 2 terms and then use the grouping, just do like we've been doing. It's going to be fine. So A is 6, B is 7, C is negative 5. So AC is negative 30. So let's start going through our factor pairs. Negative 130 adds to 29, doesn't work. Negative 215 adds to 13, that doesn't work. Negative 310 adds to 7, that's perfect. So you're just going to keep the 2 variables, and you're going to rewrite 7mn as minus 3mn plus 10mn. And we're going to take the first 2 together and then the second 2 together. So let's see, we can factor out a 3m out of the first 2. Went back to the color coding because this one's got more variables. I didn't want it to throw you off. So I'm factoring out the 3m, and then that's going to be 3m times 2m minus n plus 5n, and then 2m minus n. So I have 3m, 2m minus n's, and I'm adding 5n of the same thing. So I'm going to have 3m plus 5n times 2m minus n, and that is my factored form. Okay, negative 2p squared minus 5p plus 12. First thing I want to do is factor out that negative. That just makes our life 100 times easier. So now from there, I look and I go, okay, A is 2, B is 5, C is negative 12, so AC is negative 24. My first pair is negative 124, that doesn't work. Negative 2, 12, that adds to 10. That doesn't work. Negative 3, 8, thank goodness, that adds to 5. So I'm going to have negative 2p squared minus 3p plus 8p minus 12. All right, so let's see. Out of the first two, I'm going to factor out a p, and then I have 2p minus 3, plus the second pair, I'm going to factor out a 4 times 2p minus 3. So I've got p plus 4, 2p minus 3s, with a negative out front, which you can't forget, you got to keep it. And that's it. That's your factored form. Okay, guys, we have reviewed a ton of factoring methods. Thank you for taking good notes and paying attention for so long. That's awesome. You guys are just incredible. Thank you so much. I hope you have a great day, and I can't wait to see you in class and for us to practice this factoring.